Hello, mathematicians. In today's video, we're going to identify linear and nonlinear functions from equations. By the end of today's video, you should be able to say, I can determine if a function is linear or nonlinear from an equation. You might have noticed some typos up here on these slides. It'll say equations, not tables. Just ignore it. Just assume it says equations each time, okay? In order for an equation to represent a linear function, the equation has to be able to be written in the form y equals mx plus b. It has to be written in slope-intercept form to be a linear function. Now, we do have to remember that it could also be that y equals mx, but we determined that y equals mx is basically y equals mx plus 0, right? So you can see either way. But the important point here is that m is representing that constant rate of change or the slope. You have to have a constant rate of change to have a line. And then b just represents the y-intercept or the initial value. So that's what a linear function or linear equation looks like, right? Now, if it's a nonlinear function, it's going to have one of these three characteristics. It'll have powers other than the one on the variable. It'll have square or cube roots of variable expressions or variables in the denominator of a fraction, so on the bottom. So we're actually going to watch a video to see examples of the different types of nonlinear equations that I just described.
There are several characteristics that can be used to identify a nonlinear equation. For instance, if the simplest form of an equation includes a variable with an exponent other than 1, then the equation is nonlinear. For example, the equation y equals x squared plus 3 is nonlinear because the variable x has an exponent of 2. A graph confirms that this equation is nonlinear. This equation, y equals 4x cubed, is also nonlinear because the variable x has an exponent of 3. Another type of nonlinear equation includes a square root or cube root of a variable expression. For example, this equation is nonlinear because it includes the square root of the variable expression 2x plus 3. The graph shows that this equation is nonlinear. A third type of nonlinear equation includes a variable in the denominator of a fraction. For instance, the equation y equals 2 divided by x is nonlinear because it includes the variable x in the denominator of a fraction. A graph confirms that this equation is nonlinear. You have now seen some of the characteristics that can be used to identify nonlinear equations.
Example 4. Identify linear and nonlinear functions from equations. So determine whether the equation represents a linear or nonlinear function and explain. So we have y equals x divided by 3. Now, one of the characteristics that they tell us to watch out for is if the variable is in the denominator. It is in the numerator, so it has potential. So you have to get a little creative about how you would write this. So y equals x divided by 3, right? There's always that ghosty one here, isn't there? So that's actually the same as 1/3 times x. And is y equals 1/3 x in the form of y equals mx plus b? Technically, yes, right? It's just y equals 1/3 x plus 0, and we just don't write the 0, right? So since it can be written in the form of y equals mx plus b, the equation will represent a linear function because it can be written in the form y equals mx plus b, where m is 1/3 and b just happens to be 0. And now it's time to check for your understanding. Determine whether the equation represents a linear or nonlinear function and explain. Y is equal to negative 2x divided by 5 plus 5. So we want to know if this can be written in slope-intercept form. We want to know if we can make it look like this. Now, this can be written as y is equal to negative 2/5 x plus 5. Because it's just you can move the fraction as a coefficient away from that variable, right? And so if we compare it to the slope-intercept form, right, we have the slope, -2/5. We have the y-intercept of b. So it is a linear equation because it can be written in the form of y equals mx plus b. Example 5. Determine whether the equation represents a linear or nonlinear function and explain your reasoning. So we have y equals 3x squared plus 2x plus 5. Now on the right-hand side of my screen, you'll see I have the list of the characteristics that represent a nonlinear function. If you haven't already like sticky noted, bookmarked, or like wrote this down somewhere that you can see regularly, I really recommend you do so, because having this checklist really helps determine whether or not it's going to be a linear or nonlinear function. So let's just start at the top of this checklist, right? We've got y equals 3x squared plus 2x plus 5. Are there powers other than 1 on the variable? Well, we have 2x to the first here, right? It's always there, just you don't see it because x times nothing is just the x, right? Because x is a factor 1 time. But we then see this pesky 2 over here, don't we? Is that a power other than 1? Yes. Therefore, it's nonlinear because it cannot be written in the form of y equals mx plus b, right? So it doesn't work. It just doesn't meet all the characteristics. Now it's time to check your understanding. Determine whether the equation represents a linear or nonlinear function and explain. So we have y is equal to the square root of the quantity of 3x plus 5. Once again, I really recommend going back to that list of characteristics and see if this meets any of that criteria to be a nonlinear function. Let's take a look at that list, shall we? So over here, we've got, are there powers other than 1 on the variable? I'll just see a 3x with a ghosty 1 here, so nope. That one's good. Are there square or cube roots of variable expressions? Yes, right? This is a square root symbol, isn't it? So it does meet this criteria. But are there any variables in the denominator of a fraction? No, there's no fractions in this one. But since it meets one of these criteria, because it says 1 or more, that means this is going to be a non-linear function, because there's no way we're going to be able to rewrite this in the format of y equals mx plus b. And it has a square root in the function itself. In this video, we determined if a function is linear or nonlinear from an equation.